Hello, dear listeners. I'd like to welcome you to my presentation about low temperature subnetworks in existing district heating networks. My name is Stefan Puschnik. I work for the Energie Institute at the Johannes Kepler University uh, in Linz. And within the next minutes, I will talk about our research carried out in the project CASCADE, which was funded by the IEA DHC CHP program. And yeah, also project partners are the Italian University of Technology in Estonia, the Center of Energy Research in Norway, and the Austrian Institute of Technology. Yeah, I structured my presentation into following points. In the beginning, I give you a little introduction to the project Cascade itself and about the aim of our research, and also about the status of the project since this project is still ongoing. Then I will talk about our defined definition of a sub-low temperature district heating network and about the identified examples which we gathered within our research. And yeah, in the end, I will talk about lessons learned which we derived from our analysis and about barriers and drivers of sub-low temperature district heating networks. Yeah, I will start now by giving you some background information regarding our research. So in general, urban district heating networks operate on relatively high temperatures. So this can go up to around 130 degrees supply temperature, depending on the country. Yeah, and low temperature networks operate between 50 to 70 degrees. Yeah, we can know fourth and fifth generation district heating networks can even be lower. Yeah, and what we analyzed within our research was that we create a subnetwork by integrating a low temperature network in the return flow of an existing district heating network. And thus we have a cascaded solution, which we consider as one of the key enablers in decarbonization of the urban district heating networks. So what is the aim of our research? We try to identify the best practice examples and derive some lessons learned of existing and theoretically elaborated subnetworks. We analyze their design and how they are operated, and we evaluate also their scalability potential. And in the end, we try to develop some general guidelines and recommendations on how in the future subnetworks can be integrated. The main work from the Energie Institute side, and which was also my work, was to identify the best practice examples. And therefore, we conducted literature research with a focus on Austria, Germany, Nordic, and Baltic countries. We conducted several district heating operators, either via mail, via expert interviews. We had also expert meetings and tried to gather as many examples as we could. And from that gathered examples, we derive some lessons learned. Yet the work, which is still ongoing from our partners, are the Tallinn University of Technology in Estonia is working on the barriers and enablers and describe their triggers for implementation. So that I will present in the end of this presentation. Center of Energy Research works on the technical solutions. So they try to analyze the connection and the control of the single sub-low temperature networks in case areas via dynamic simulations. And the Austrian Institute of Technology, they conduct techno-economic analysis and scalability analysis of sub-low temperature networks. You can see here now how we define within the project a sub-network. You can see here the superior district heating network, and you can see here in the green dot dashed lines the subnetwork, which is here. And you see here the integration of the subnetwork into the return flow of the superior district heating network. And there's also an additional connection from the supply flow of the superior district heating network to guarantee always a continuous supply temperature. And what are the advantages? You can also integrate now in the sub-low temperature networks renewables like solar or geothermal. And you can also integrate, for example, waste heat, which is low temperature. And what we analyze is also this connection point, how to integrate the subnetwork into the superior district heating network. And the four main requirements which we have is that it has to be connected, the subnetwork, to the superior district heating network. the subnetwork must primarily use the return flow to cover the energy demand, and the subnetwork must be low temperature, and there must be more than one customer to be really a network. I will talk now about the results of the identification process. So in total, we could identify 29 examples which we analyzed in detail. And from those 29 examples, which is illustrated here in this waterfall diagram, only 4 did meet our generic definition and were implemented in practice. And those examples were located in Denmark, that was Lystrup and Sonderby, and there were 2 also in Berlin, Adlershof and in Mannheim. Further, 10 examples were implemented but did not meet our generic definition. So there was, for example, not a real network connected, or they did also use mainly the supply flow from the superior district heating network instead of the return flow. There were 5 examples which were only theoretically elaborated, and from 10 examples we do not know the status, and it was not able to find that out. And as you can see, the main examples come from Austria, Denmark, and from Germany. I will give you now a compact overview about what we learned within our analysis. Although subnetworks are not that well promoted or established, they are often considered at least operative as day-to-day business. There exists organizational hindrances within companies regarding when should subnetworks be integrated. That's always favorable if there are new city districts, if there are new buildings. If you integrate this subnetwork, you can increase the capacity of the overall district heating networks. The connection points, so the control is very complex and potential risks can occur. And regarding the location, it's always good to locate it near the heat generation unit, since there is the mass flow sufficient. In the end, I will talk now about peers and the neighbors of sub-low temperature district heating networks. There's currently a survey ongoing from our project partner, Tallinn University of Technology. And this survey is based on previous research, on case studies and previous projects, on workshops with experts, and on interviews with district heating companies. So in the survey, you have in the beginning a short introduction about the sub-low temperature network concept, and then you have the possibility to evaluate specific barriers, like technical ones, like hydraulic issues, or non-technical ones, like high investment costs, or also on drivers. So what could drive a sub-low temperature network integration in the future. And you can evaluate them from very important, which is 5, to not important, with only a score of 1. And yeah, we would be happy to receive your feedback on this. I will give you the link on the next slide. We contacted already several experts like the IEA DHC member countries and Baltic states, and we also contacted the other district heating companies and suppliers within our project network. We received already feedback from 85 participants, where 42% were from district heating companies, 18% from engineering companies and technology providers, and 40% were from academia and research organizations. As you can see in this figure, the figure is structured regarding country and background. You can see that especially Estonia has a high feedback rate. Yeah, we would be happy if we have from further participants that we have more feedback and we have more meaningful results. So just use this participation link here, or you can also use the QR code to give us your feedback on sub-low temperature district heating networks. And it will only take you around 5 minutes to fill out the questions. That's now basically all from my side. If you have any further questions, don't hesitate to contact me. And I say thank you for your interest in my presentation in our research. Thank you. Bye.